Hello friends and welcome to lecture number 6 of the basic course on engineering circuit analysis. So after completing the concepts of voltage, now is the time to understand a new concept which is power. So let's start with the definition of power, which is the power is the rate at which work is expended, or we can tell that the power is the rate at which work is spent, or the rate in the sense it is work done per unit time. So clearly when it is work done per unit time, if I call the power to be represented by the letter P, it is work done per unit time, right? Work done per unit time. Work done per unit time. So if you see the unit of the power, in SI units, naturally work done will be in joules and time is in seconds, it would be joules per second. So what is the unit of power? This joules per second, for electrical engineering, we use the quantity watts. Okay. So it is represented by this capital letter W. So maybe 10 watts, 9 watts. So this is the representation of power. Now we have to calculate an expression for power, which we will be doing with a different method. So first let us find what is the unit of the quantity when I multiply voltage and current. Okay, so we will be doing this by dimensional analysis. So voltage, you know that it is the work done per unit charge. So this is work done per unit charge, and current, you know that it is the charge flowing per second. So it is charge per time, right? So I'll do the unit dimension analysis here. So work unit is joules. So the unit of work is joules divided by unit of charge is coulomb. So we can represent it by capital C, multiplied by, again here it is Q is represented by charge, coulomb unit, and this is second. So if you cancel these, you will finally get the quantity voltage multiplied by current. Voltage multiplied by current, the unit is joules per second. Joules per second. And that is what we have derived here also, right? This is also joules per second. So we can write an expression for power to be equal to, power is nothing but voltage into current. This is a very general expression of current. As you understand more and more circuits when you study the AC analysis, etc., this equation will have more and more quantities added to it. But generally, we can tell that power is nothing but voltage into current. This is a very important expression that you have to remember. Now, another very important concept that you have to understand for engineering circuit analysis is the passive sign convention for power. And it is very important that you understand this. Now look at this circuit. So let us have this circuit element here. I will represent it by CE. You see that there is a voltage applied here. We have seen voltage in very much depth, so you understand what is this. I'll just mark the terminals also just for namesake. So this is terminal A, terminal B. The voltage applied across the terminal A and B is plus 5 volt, or the voltage across the terminal AB is plus 5 volt. And you can see there is a current which is going into the circuit element, right? This current is going, this current of 2 amperes. Let me take a different color here. This current of 2 amperes is going into the circuit element. So the current enters the positive terminal of the element, right? The current enters the positive terminal. See, this positive, if I am writing here, I can write it here also. It is the same thing. It's not that I have to always write it right below the letter A. I can write it here also. It is same. It is the same wire, right? So the current enters the positive terminal of the element. So it looks like this current is being actually pushed into this element, right? This current is being pushed into this element. It looks like the element is actually absorbing power because the current is being pushed into the positive terminal of the element. It looks like the element is absorbing power. So when it is this case, whenever the current is going into the positive terminal of the element, in engineering circuit analysis, we tell that the power absorbed is positive. This is the sign convention. The power absorbed is positive. So what will be the value of this power absorbed? So we will write like this. This is a general method that you have to follow. So because the current is going into the positive terminal, the power absorbed will be positive. And what is power? You know that power is nothing but voltage into current. So you write the voltage value, multiply it by the current value. So what is the voltage value measured? It is 5 volt. Okay, you just take this value, whatever it is measured, take the value and put that value here. So this plus 5 volt multiplied by the current value. What is the current value? It is 2 amperes. So the power absorbed here is plus 10 watts. The power absorbed by the circuit element is plus 10 watts. So the statement here that we have to understand is that whenever the current enters, I'll just take a different color. Whenever the current enters the positive terminal of a circuit element, okay, this is important. When the current enters the positive terminal of a circuit element, then that element absorbs power. Or the power absorbed is positive when current enters the positive terminal of the element. It's a very simple statement. The important thing is that the power absorbed is positive when the current enters the positive terminal of that circuit element, which is looking like this. Okay. Now let us take the next sign convention. Now in this case you can see this is the positive and negative of the circuit element here. This is the positive and negative of the circuit element. You can see that the current is leaving the positive terminal, right? In the previous case, the current was entering the positive terminal. Now the current is leaving the positive terminal. So in this case, what happens? The statement is the current leaves the positive terminal of the element. Right? The current leaves the positive terminal of the element. So it is looking like the current is being pushed out of the element. Right? The current is being pushed out of this element. So it looks like the element is generating power. Right? When the current goes into the element is absorbing power. And when the current is leaving the positive terminal of the element, it looks like the element is generating the power. So in this case, in engineering circuit analysis, how do we write this? So whenever current leaves the positive terminal of the element, this is the positive terminal, the current is leaving. In that case, we write the P generated. The power generated by the circuit element is positive. Okay. And you multiply it by the voltage and multiply it by the current and you will get the power generated. So P generated is equal to plus the voltage value, how much they have given? 5 volts. The current value, how much they have given? 2 volts, 2 amperes. So this is 10 watts. So this circuit element is generating 10 watts of power. Okay, so this circuit element is generating 10 watts of power. So we will do once again a revision of this. So whenever current leaves the positive terminal of the circuit element, the element generates power. Or we can write P generated is positive when the current leaves the positive terminal of the element. Okay, so that is the simple statement. So when the current leaves the positive terminal, P generated is positive. When current enters the positive terminal of the element, P absorbed is positive. Okay. Now there might be a case where somebody might give you a scenario like this. So here you see the voltage, they have given it as a negative value. Okay, they have given it as a negative value. I've already told you, whenever they give the voltage as a negative value, you don't go around changing the polarities to make the voltage positive. You don't have to do that. Sign convention will take care of that. Now you can clearly see, now forget about this negative value. You can see that the current is entering, the current of 2 ampere is entering the positive terminal. Forget about this value now. Don't consider this value. The current is entering the positive terminal. That means current enters the positive terminal. Right? So what will be P absorbed? P absorbed will be positive here. Okay, and you have to multiply the voltage and current value to get the P absorbed value. So what is the voltage value? Now put the magnitude. Now they have given the voltage as minus 5 volt. Just put it as minus 5 volt directly here. Okay, and the current value is given as 2 ampere. Just put the current as 2 ampere directly. So you will get P absorbed to be is equal to minus 10 watts. What does this negative sign say? You thought that the element was absorbing power, but this negative sign tells us that the element is actually generating power. It is not absorbing power. Okay, you see here. So don't change the dot polarity. It's not dot polarity. Don't change the polarity here. See, the current enters the positive terminal of the element. This is like current is being pushed into the element. Right? It looks like the element is absorbing power. So you follow it in the same way. But finally, you get a negative value here. This negative value shows the power is being generated. Power is not being absorbed, but power is being generated. Okay. Usually, I will never reverse the polarities. But for just this academic sake, I will just reverse the polarities and I will show you. So I will just reverse the polarities here. I'll put plus here, I'll put minus here, and this V then I will have to change to plus 5 volt. Right, now these two circuits are exactly the same. Okay, these are equivalent circuits. Now the current is going like this. Current is equal to 2 ampere flows here. It will flow through the element. Right, it will flow through the element and it will come out of this terminal. The current has to come out of the terminal, right? It is going into one terminal, it has to come outside the other terminal. So I is equal to 2 ampere. Now let us analyze this case. So in this case you can see this is negative and this is positive, right? So in this case you can see the current comes out of the positive terminal, right? So in this case what it will be? Power generated will be equal to positive, right? Power generated will be equal to positive. So take the voltage multiplied by the current. So the voltage is now 5 volts and the current is now 2 amperes. So you will get plus 10 volts. So clearly you got the result that power generated is equal to plus 10 watts, right? So that is what we have done here also, right? This is the same circuit. So power absorbed was minus 10 watts. When I just changed the polarity for your convenience, I got that the power generated is plus 10 watts. Both are exactly the same. Just like the voltage you can reverse and then you can reverse the magnitude. Current direction you can reverse and you can reverse the magnitude. Similarly, we can do that for power generated and power absorbed also. Okay, so here power is being generated as 10 watts and that value you have found here. Now, because these two circuits are equivalent, you can clearly make a relation between these two quantities. Clearly you can see power absorbed is nothing but minus power generated. Power absorbed is nothing but minus power generated. Just like you saw for current, voltage, here also we can use this phenomenon where power absorbed is equal to minus P generated. So this is also a very important equation. I hope things are clear. In the next video, we will be doing some numericals associated with this so that if there is any confusion remaining, that will get solved. So thank you.